Lesson 4, Transformations. So this is the last lesson in this unit, and we are still hoping to test next Thursday, April 9th. So if we haven't been doing a lot, please try to catch up on the work that's been posted so that you're ready for the test on Thursday, April 9th. Transformations performed on any polynomial function f of x to form a new function g of x can be described by the transformational function below. This top portion of the notes is the exact same table that we've seen on lots of different notes sheets because transformations are the same no matter what type of function you're talking about. So the a value in the front is always affecting your vertical stretches and compressions, and then if it's a negative, it's a reflection over the x-axis. The b value, which is inside the parentheses right in front of the x, that would be your reflection over the y-axis. If it's negative, it's your horizontal stretch and compression. The c value that's inside the parentheses, being added or subtracted directly from the x, that's always your horizontal translation. And remember, it's always the opposite of what we think it should be. And then the d value in the back, that's not inside the parentheses, that's your vertical translation, and it's as it should be. Up is positive, down is negative. So, keeping all of that in mind, we want to try out these problems below. Number 1, for each, describe the graphical transformations on m of x equals 8 to the x to produce j of x. The thing that I think makes this extra tricky, the 8 is built into the parent function. So the 8 does not count as a vertical stretch or anything. It is built into the parent function. So when I look at part A, that negative sign in the front is going to be your reflection over the x-axis. And then since the x is normally in the exponent, that minus 3, you could kind of think of that as being inside parentheses. So that minus 3, that's going to be a horizontal translation. And since horizontal translations are always the opposite of what we think they should be, you're going to go right 3. So horizontal translation, right 3. That 9 in the back, since it's not inside parentheses, and again, I know you don't see parentheses, but let me just add them in where they would be. They would be right here in pink. Those would be the parentheses. So that plus 9 is not in parentheses. So that's your vertical translation up 9, because the vertical translations are as they should be. Up is positive, down is negative. Why don't you pause the video and try B and C? On B, remember that 8 to the x is the parent function. So anything that's different than 8 to the x, those are all the transformations that we need to account for, that we need to mention. So this 3 in the front, it's being multiplied by the function. So that's going to be a vertical stretch since 3 is greater than 1. If that 3 had been a 1/3, then it would be a vertical compression. So if the a value is greater than 1, it's a stretch. If the a value is in between 0 and 1, it's a compression. So that's a vertical stretch. The 8 is just part of the function. So the next thing we're looking at is this minus sign right here. And remember, it's like we have parentheses around that x. So that minus sign right here, that's going to be a reflection over the y-axis, because it's happening inside the parentheses. And then that minus 2 in the back is not inside the parentheses, so that's a vertical translation down 2. For part C, the 1/2 is being multiplied by the x directly. So that would be equivalent to the b value. If you're looking at the table up above, that would be the b value. So the b value is a horizontal transformation. So the horizontal transformations are weird. They're always the opposite of what we think they should be. So since it's a 1/2, that's actually going to be a horizontal stretch. If that 1/2 had been a 2 or a 3 or a 4, basically anything bigger than 1, that would actually be a horizontal compression. Because again, the horizontal ones are the opposite of what we think they should be. On number 2, given the parent function f of x equals 2 to the x, write an example of a transformed function g of x that has been vertically compressed. So I'll do g of x, just because that's what they tell us to name it. And then we want to do a vertical compression. Vertical compression. So that needs to be in the front, and it needs to be a number in between 0 and 1. So I'm going to do 1/3 times the original function was 2 to the x. And then I need to also move horizontally to the right. So that would need to happen directly to the x that's in the exponent. And since I'm going right, I actually need it to be a minus a number. So -3, -7, -12. The last one, a vertical translation down. So in the back, a minus. So -8, -1, -1 billion, whatever you want it to be. Why don't you pause the video and try 3? So on 3, this time our parent function is 4 to the x. So we're going to start with g of x equals, and then we have our 4 to the x. And then let's see what they want us to do. So we want to be vertically stretched. So that means I can multiply the whole function in the front by any number greater than 1. So I'm going to do an 8. As I keep reading through, it says I want to be reflected over the x-axis. So I need to squeeze a negative sign in front of that 8. I'm going to make my equal sign a little bit smaller to fit that in. So equals. So -8 for the reflection over the x-axis. And then for the horizontal translation to the left, that would have to happen directly to the x. If I'm moving left, I actually need it to be a plus a number. So +1, +2, plus anything. And that would be it. For number 4, the graph of f of x equals log of x is shown. Use the graph of f of x to sketch the transformed function m of x equals negative f of x minus 3 minus 5 on the coordinate plane. Then state the domain, range, and asymptotes of m of x. So basically, we just want to spell out what all those different transformations are and then actually sketch the new function on the graph. So that negative sign in front is your reflection over the x-axis. Your -3 is going to make you go right 3 because it's inside the parentheses, so it's horizontal. It's always the opposite of what we think it should be. And then that -5 in the back would be our vertical translation down 5. So as far as us actually doing this graph, the one point that hits nicely that I see right away on the graph is 1, 0 right here. So I'm basically going to kind of shift everything with respect to that point 1, 0, but then also with respect to our vertical asymptote of the original function. So the original function would have a vertical asymptote at x equals 0. So basically, since I'm moving to the right 3, my new vertical asymptote, instead of being at x equals 0, so let me put that in here. So here's x equals 0. So if I'm going to move that to the right 3, I'm going to switch up my colors. I'm going to go 1, 2, 3 to the right. So here's my new vertical asymptote at x equals 3. And I'm going to go ahead and write that down off to the right side because they ask us for the asymptote of m of x. So I move to the right 3. And then that purple point on the original graph also needs to move to the right 3. So 1, 2, 3. So right here, and then down 5. So I'm going to go right 3 and down 5 for that purple point that normally was at 1, 0. So 1, 2, 3 to the right, 1, 2, 3, 4, down 5. So right down there. And then what else? A reflection over the x-axis. So a reflection over the x-axis basically means that that function is turning upside down. So it used to be how it was graphed originally. So if I want to flip that over, it's basically going to look like this now. So there's my new graph, and I should label it m of x. And again, it has an asymptote at x equals 3. Its domain would be 3, infinity. And then its range should be everything. It should be negative infinity to positive infinity, because it's going to keep going up forever. It's going to keep going down forever, ever so slightly on this end right here. So right there, it's going to keep going down ever so slightly forever and ever and ever, and then it goes up forever over here. So then that should be it for that one. And then the last one, they have a logarithmic function graphed for us, and then they want us to graph k of x, which is f of x plus 5 plus 2 on the same coordinate plane. So very similar to what we just did. So the plus 5 is inside the parentheses, so it has to be horizontal, has to be the opposite of what we think it should be, so left 5. The plus 2 would be up 2. And then actually, we just kind of answered part A. So let me just be lazy here and just say this is here, this is here. So that's how we're going to actually move those reference points. We're going to go left 5, up 2 for all 3 reference points. So I'll actually do that right now. So left 5. I'm going to start with this point right here that was originally at 3, 1. I'm going to change colors. I'm going to go left 5 and up 2. So right about there. Then I'm going to do this point that was at 1, 0, and I'm going to move that one left 5 up 2. And then that last point is a decimal, so we're going to have to eyeball it a little bit. We don't know exactly where it is, but we do know its y value is -1. So I'm going to go left 5 the best I can. And then I'm going to go up 2. So it should be right about there. Oh, that's a little off, but you kind of get the idea. So as far as the asymptotes go, originally, if I switch back to blue, originally we have an asymptote at x equals 0, but since we're moving left 5, I need to move the asymptote 5 to the left. So now our new asymptote should be here at x equals -5. So let me make sure I'm labeling these correctly. The original graph was f of x, that's the one in blue. So its asymptote was x equals 0. And then the new graph was in red, that's k of x. So that asymptote is going to be at x equals -5 since we moved left 5. And then don't forget to actually connect the dots over here the best you can and label the graph k of x. And then did we do everything they asked us to do? I believe so. That's all.